Good evening. I'm Donovan, and before I forget, I want to thank very much Stu and Corey for inviting me to talk this evening, and thank you all very much for coming out to see this talk. I hope it's of interest and it's useful to you. Before I start, I just want to draw attention to this thing going on behind me. You may have noticed some tweets appearing on the screen. This is the part we're going to talk about later on. What's happening here is we've got a Node application that's running and is searching Twitter for the hashtag refresh Dublin. And anytime it sees a tweet, it puts a tweet at the top of that list. And it's quite a good use of Node. It brings a few of Node's advantages to the front and shows how to use it. So we're going to talk about how this is done a bit later on. But before we start, a bit about myself. I'm Donovan Hutchinson. I'm a front-end web developer. I haven't always been a front-end web developer. I used to work with the likes of PHP and server-side technologies. I've done a little bit of graphic design over the years as well and worked with various companies. And if you have any questions after the talk, feel free to follow along on Twitter there and send any messages through to Twitter. I'm going to follow up the talk maybe with a blog post about how the Node app I talk about today. And at the same time, if you want to look up the talk afterwards, you can look it up at hop.ie/go/node. You'll see the slides online. So the plan this evening, we're going to talk firstly a bit about what Node is and what goals it tries to achieve. Talk a bit about what kind of frameworks you can use with Node and how you can produce things with that. Being a front-end web developer, I'm going to focus mostly on web side of things, but it goes further than that. And then we're going to create a basic web app using a thing called Express.js. I'll talk through the steps to show that it's relatively straightforward to actually set up your own web application. And to follow up from that, we'll show a full example application that you can download from GitHub and check out yourself. It's a working app. And I'll show how that's built and some of the techniques that go into that. And then afterwards, if you want to catch up for any questions, I'll be available over some pints afterwards. So to begin with, can I ask who here has used Node.js before? A few hands. That's cool. I'm hoping for good questions from you guys then. Who here has used JavaScript before? Everyone, pretty much. It's kind of ubiquitous. Everyone uses JavaScript. Well, Node is a JavaScript-based software platform. It's itself written in JavaScript, but also everything you write for it is based in JavaScript. It's described as a software system because basically it's like a layer on which you can do things with your computer. It's not a web server, and it's not a specific piece of software like that. It's a way of creating web servers or creating anything you want that does any kind of interaction with your computer and the files on it. It tries to do a few things, and you may have heard these phrases bounced around in relation to Node, in that it's non-blocking and it's event-driven. I'll talk a bit more about what non-blocking means in a second. And event-driven, just to touch on it for a second, it's more the way you write your applications in Node is that they listen and respond to events. Everything is based on the idea that something happens, whether it's somebody visiting a website or posting data somewhere or file contents changing. It triggers an event, and you wrap functions around that, so things can be triggered by these events and then have their own actions. And in terms of Node it's been quite young. In terms of its development, it's relatively recent. It was launched in 2009. It's not brand new. It's been around for a few years, and it's actually approaching version 1. But it's at an interesting point in that it's still young enough that the community is very vibrant and enthusiastic, but it's got a lot of support. It's established itself quite well, and there's lots of great stuff going on with Node at the moment. So to come back to the point of non-blocking, I'd like to illustrate the difference between blocking and non-blocking by way of a metaphor. If you picture the way a doctor's surgery works and contrast that to the way a fast food outlet works, you walk into a doctor's surgery, you go up to the desk, you give your name, maybe get a form to sign, sit down and wait. And the doctor sees one person at a time. And when the doctor is seeing a person, everyone else has to wait. That's essentially a blocking process. It's different than a fast food outlet where you go and place your order, and then you can stand to the side and you wait, and the next person can come and place their order, and more people can keep placing orders while you wait for your food to come back. You're not standing blocking the counter for other people to place their order. So in software, if you're using perhaps something like PHP or any kind of server-side technology like that, the programs you write are blocking in that when you have a request to go somewhere and get some data, say from a database or from the hard drive, the system or the thread that is on will wait for the data to come back and then carry on running the program. But Node's a bit different. If you have an operation like that where it goes to get some data from a hard drive, it'll carry on running and run everything else in the program while it waits for that to come back. And the data will come back when it's ready, and something else can be fired at that point. The reason why this is important, these numbers refer to the number of essentially CPU cycles that can be carried out in the time it takes to get data back from various levels. Up at the top, we've got level 1, level 2 cache. That's right within the CPU. It's very fast to get data back from that. We're talking maybe 3 or 14 cycles to get data back out of the CPU, which is essentially nothing. But a little bit outside of it, to RAM, which we know is very quick, can still be around approximately 250 cycles of the CPU to get that data back. And if you go further out again to disks, to hard drives, it's up to the millions, maybe 40 million cycles. In the time it takes for that to come back, the CPU could have ticked over 40 million times. And it gets even worse if you're talking about networks across maybe web services or going to different servers to get information. It can be orders of magnitude higher than that. And what Node tries to do, it tries to eliminate this being an issue. Well, the reason why it's an issue, actually, just to come back to that, modern operating systems have threads, and threads can be spawned to have multiple threads going at the same time that get around this issue. The whole system doesn't lock up, but rather it can spawn more threads. So if you have an Apache server that's running some code, it can spawn another copy of itself while it's waiting for this data to come back, or if another request comes in. And that's grand, really, but it does use up a lot of RAM. It uses more resources. It's essentially expensive for computers to do that. Node, on the other hand, is a single-threaded approach in that it doesn't have multiple threads. Everything happens in one thread. And it handles that one thread by making use of this gap in the I/O. Every time it's going out to get something like data from a hard drive, that's a massive gap of time. It could be doing other things, and it takes on other events through what's called the event loop. It keeps looping around, getting more stuff and doing more things while it's waiting for this data to come back. And something it tries to do is it tries to be very fast. It achieves this by being built on something Google made called V8. It's a JavaScript engine that Google made for their Chrome web browser. And what Node essentially is a wrapper around this engine. It gives you the tools to build software that makes use of V8, which is renowned as being a particularly fast processor for JavaScript. So if you're getting into Node, what kind of apps would you want to make? This diagram comes from the Node website, and I think it quite nicely illustrates some of the idea of what Node is good at. It represents a series of dots scattered around the place, joined up with various lines, which you could think of as small pieces of software performing specific tasks. And what Node's very good at is creating these small pieces of software that do specific tasks, and they can pass data around between themselves. And why that's great is that if one part was to fail, it doesn't bring down the whole system. It's easier to upgrade various bits, and it doesn't become one big ball of mud in terms of software. In the real world, in terms of what apps that might be, you could use Node for any sorts of apps in terms of web apps, but ideally you could use it for apps that have to just serve data quickly. Say you're making an application for a phone and you need a back end for it, you could create a JSON endpoint for your application, and you'd have a very responsive, quick back end for getting data to your phone application, and it would help back up your other parts of the software. And something Node comes bundled with is NPM. It's Node Package Manager. Node Package Manager is a way of distributing the modules that the community makes for Node. At the moment, we're talking about 30,000 modules available. They provide software for all sorts of tasks, basic small tools for handling HTTP requests, up to full frameworks for developing full complicated applications. And it's all managed internally within NPM. If you've ever used anything like Bundler, if you're using Ruby on Rails, it goes out, gets the modules for you, installs them in the right place, and takes care of dependencies as needed. So we'll get into the Node itself here. We have a full working Node application. It doesn't do a lot, but this is, in its entirety, it's a working app. You could put this into a file and run it as a Node app, and it would work. But the reason I've chosen this example in this case is that it illustrates a bit about the non-blocking nature I mentioned earlier. What this app's doing, it's requiring a module called file system, and it's reading in a file called hello.txt. It's then logging the contents of that file to the terminal in this case. And it's also logging out the phrase hello from Node. Typically, if you're working at a top-down approach of the way a blocking application would work, you'd see two logs come out of this. You'd see the hello from disk first, and then you'd see hello from Node. But the way Node works, I've created a race condition in this, but it's pretty obvious what's going to happen for Node in that it's going to take so long to get the text back from the hard drive, like talking order of magnitude or millions of times longer than just going on to the next line, that what you'll see is hello from Node and then hello from disk. And I can illustrate this. If I go to the terminal, let's make it full screen here. If I show the contents of example.js, we can see it's just the same as what was on the slide. It's reading in the file and it's logging the contents out. We run it with the command node example. And here we see it says hello from Node, and then later it says hello from disk. So it's not a terribly useful app, but it's a starting point. And taking it a bit further on, we can actually make a more useful app, just a couple more lines of code. In this case, this is a full working web server. It doesn't do a lot in terms of web servers, but it does actually respond text to the browser if you visit it in the browser. And what this is doing, just to quickly step through the code, it has a module at the top that's being required, the HTTP module. And that gives you a lot of tools for creating web servers and for listening to HTTP requests. And what it does is it creates a web server, which then calls a function, and that function listens for hits on the web server, and the function returns, in this case, hello world. And lastly, we're telling it where to listen for connections. We're saying server.listen 1337, that's telling it to listen to the port 1337. We can run this in the same way we ran the example. Here we have the same code as before. And the notification here says we have an application running at port 1337. So we'll go across to our web browser, open a new tab, and there we have it, hello world. So if you want to go beyond just saying hello world, there are lots of apps that make it easier to make complicated but useful applications. Frameworks. These mostly are available through NPM or through GitHub. You can also use them. Some are larger than others. Some are handy tools. In this case, I'm going to highlight 4, which I find pretty interesting. Express.js is something I use a lot. It's like if you ever used Sinatra, in that it gives you the framework for building a web app, and you can set up an app that listens for certain endpoints. It can listen for a home page, get requests on the home page. You can listen for post requests for maybe subscribing people to various services. And it gives you a framework for building that kind of application. Other sorts of uses, though, Meteor is quite an interesting one in that it provides a framework for making real-time apps. It provides the data storage locally, the data storage on the server, and it passes the data between the two. So that if somebody was to, say, click on a map and add a marker to it on an app, that information is immediately relayed to the server, and everyone else looking at that will see the marker appear at the same time. It's useful for games or anything where you want to see an immediate response on the screen across everybody's screens looking at the app. And then there's Sails. Sails is like the Node equivalent of Rails, except it's more of a JSON-oriented. It creates an API for JSON endpoints for your app. And that could be useful if you want to maybe make the likes of a server that's helping an application out if you're writing an iOS app or something and you want to have some solid responsive back end to it. And then lastly, there's Hoodie. It's a handy app for setting up starting points for websites that need to have user registration. It can give you a login form, lost password form, and a basic admin area at the back, just straight away out of the box. So let's go one step further and actually create an app. We're going to use Express.js to do it. Firstly, we'll shut down that server. And I'm starting from the point here of just having installed Node. So I've gone to nodejs.org and run the installer for OS X. It also has installers available for Windows and for Linux if you need to compile it on Linux too. And when you install Node, it comes with something called NPM by default. So you can use NPM to install other modules. I'm going to use NPM to install, in this case, Express. And I'm going to add a modifier or flag G, which stands for global. And what it's doing is it's going to go out there, get Express, and put it at the root of my user directory so I can use Express as a command elsewhere to create my own apps. And it's finished. It's come back, and it's given me what I need now to make apps using Express. To do so, I can run the express command and then give it a name. So I'm going to make an app called my app. And that's gone ahead and made an app. It's made a folder structure for the initial starting point for the app. And I've put a few files in it as well to get me started. The first one I'm going to talk about is package.json. That's a way of managing your dependencies. If you have modules, you want to include them, and you want to distribute your app, people can then install it using npm install, and all the dependencies listed there will be included in your app. The second file down is app.js. That's where the core of your app lives, and all the essential logic can be put there if you wish. You then have a public folder where any static assets like JavaScript, CSS files, images, and then we have two folders which deal with the routing logic and the views. So you have functionality around specific endpoints in your routes, and then your views contain templates. So I'll set up the app and get it going here. If I cd into my app and run the npm installer, this is looking at the package.json file and is going out and getting the files it needs from that. In this case, quite a few. It's got cookie stuff. It's got various tools for dealing with concatenating and compressing JavaScript files. And what it does, it gets all those files, it puts them into a folder called Node modules. We can leave that folder where it is. It contains just the modules that it uses. And to run this app, we now run it with Node app. It says it's listening on port 3000. So let's go across and verify that. On localhost 3000. And here it says, welcome to Express. Now I'm going to take a look at what's actually going on here. I'll shut down the server and we will open it up in Sublime Text. If you can see that, it's a bit small on the side there, but it's a list of the folders I mentioned before. We've got the public folder for static assets, the routes, and the views. I'll start off in the app file, and we'll talk about what's going on with this. The first thing it's doing is it's calling in some requirements, which are modules that it needs to work. In this case, it needs the Express module, it needs some routing information, it needs HTTP module and paths, so it can deal with the paths we're giving it. It knows what we say. It knows what we mean when we say slash or slash subscribe or slash about. And then you have some settings. In this case, we're setting the rendering engine being Jade. We're telling it to look for the static assets within the public folder and some logging information. But the most interesting part here that's going on is the line app.get. That's telling the application it needs to listen for a GET request at, in this case, the URL is slash, which is the home page. And when it gets a GET request at that URL, it runs a function as a callback. And that function is routes.index. As I mentioned earlier, a requirement at the top here was the routes folder. So everything within that folder has been called in, and any functions within that can be accessed, in this case, by routes.function name. So we can take a look and see what that function is. In the routes folder, there's a file called index, and it has a basic function in there that just tells it to render a view called index. And more than that, it's passing a bit of data into that view. In this case, it's the title. So we can change this title. We'll change it to refresh Dublin. And take a look at where this is going. In the views folder, there's a file called index.jade. And it's using something called Jade. It's a HTML preprocessor. Has anyone here used Jade or Haml or anything like that for HTML? A few people. It's a way of writing HTML without actually writing all the closing tags and the opening tags necessarily. It's white space dependent or significant in that any tabs are used to imply that the content is within the tabbed in part. So in this case, the block content, everything beneath it is tabbed in one tab. And when it processes that, you have a content block, and it will actually process that as if anything that follows it is inside that block. A couple of things to look for here. We can add variables to this Jade file, and they can be defined in two ways. Either by adding an equal sign after the HTML tag, in which case there's an h1 HTML tag here, and the equal sign then says anything that follows this is logic, it needs to be processed. Or if you have a string, you can put a variable in the middle of that string using the hashtag and the curly braces. And this is an extension of the general layout file itself, which it might look a bit more like an HTML file. You see some elements in there. It starts with a doc type, There's an HTML tag that everything else is indented one tab within it, so it's contained within HTML tags. And the block content means it takes everything from, in this case, block content, H1 and the P, and sticks it in there in the body of the document. So we'll go back and see what's going on with this. We're listening again on port 3000. Try refresh, and welcome to Refresh Dublin. So that's a full application. We can push that application out to Heroku or to Appfog and have it live on the web, and that's a working app. It won't necessarily do a lot more. It'd be a very welcoming app, but it's a starting point, and you can then add more functionality to that, include more modules, and start doing more stuff with it. It gives you a framework to get going with the web app. So I'm going to show an example of a real app I put together last week. It's something I'm calling tweets. Now, the problem it's trying to solve is one of, can I ask, has anyone here used the Twitter API? And has anyone used the public API then in terms of getting tweets using JavaScript? Yeah. And you'll know then that the pain that has been inflicted recently by Twitter in that you can no longer do that. You can't just access public API without using authentication anymore. What Twitter have done is they put a layer of authentication in place that you have to have an app registered, it has to have credentials and a secret code. And that information isn't the kind of information you want to put on your front end. You don't want to put it into the JavaScript in the publicly accessible part of your site. So a solution to this is to move it to the back end, to put it on the server side. And something I've attempted to do with this is to make a Node app that just deals with the basic part of going to Twitter and getting search results and then returning them as a JSON endpoint, so that in the future I could build more basic front-end applications and rely on this as a means of getting that data. So now to show it in action, I'll go to the actual endpoint and show what it's producing. If I put this through, it's parsing the URL and seeing search in the URL. So it's going off and doing a search and returning a bunch of JSON, which is the JavaScript way of encoding data. And this is a whole set of tweets. If I do a search for text on this, you can see someone's talking about Microsoft points here, and various tweets come back. And that's not a lot of use by itself, but if you use maybe some front-end JavaScript code, you can put that through a template, and you can put it into your page, and you can make use of these tweets quite easily. And that's what's happening here on the tweets page. I have a jQuery plugin that takes that information and puts it onto the page. That's only one half of it. The second half, as you might have seen earlier, is that the tweets are updating live in real time. That's something Node is extremely good at, and something that's it's built upon the idea of using streams. And this could be streams of data, where data can be parsed, sent around the place in chunks rather than moving entire files around. Or it could be used in conjunction with web services to allow sockets to be opened up to the service and have a constant stream of data as it arrives sent out. So what was happening was the browser is listening all the time to a socket, and anytime a tweet arrives with a specific search attached to it, that tweet triggers an event which tells the browser to update. It sends the data to the browser and it updates on the page. Now to show what I mean, I'm going to show some code and talk through a bit about what this app's doing. So this is the full application that deals with getting searches and doing the streams. It's not a lot of code. It's only about 100 lines or so. I'll start at the top. It has a few requires. It's requiring the HTTP module for you doing web stuff, file system stuff as well, and Express for handling the URLs. And also uses Redis. If anyone's used Redis, it's a memory-based, kind of a database way of storing documents in memory. Something if you need to keep in mind if you're using Twitter is that they're very strict on their rates, the rates by which you access the service, the number of times per minute or per 15 minutes. And to get around that, I cache requests in memory, and I use Redis to do that. And then something I do is I set up some basic environment variables so that the environment variables contain things like the authentication the app needs for Twitter, and tells it where to listen, in this case, port 5000. I then create a server. And the server itself can have some functionality attached to it through a thing called Socket.io. I'll get to more detail about what Socket.io is doing, but that's the part that deals with the streaming and the live updating of the data. So connect to Twitter, establish a connection to the database, and then this is where the core of the app, the main stuff happens here. Firstly, it's listening for a GET request at the search URL. Anything after the search URL is passed in as a parameter to the search. It builds a search phrase, it then checks the database to say, is this available in the database? If not, then it goes to Twitter and it says, give me the latest search. And then save that in the database and expire it in a minute. So it would only save it for a minute, but it gives us a bit of a buffer. And then the other half, the first half is searching. That's the first bit the app does. It gets the initial search and returns it to the browser. And then after it's got its data, it wants to sit there listening for more stuff. So it opens up a socket. And this is the part that listens for that connection. There's an event called connection that Socket.io listens for. In this case, it's listening for the connection. And when it's streaming the data, it's streaming it from Twitter using a thing called Twitter Stream. This is built on some existing modules. I didn't write all the code to handle this. There's something called InTwitter. And it has some handy methods that allow you to pass through searches and request streams. And it deals with the heavy lifting of actually taking care of how to communicate with Twitter and to do that the right way. And what the streaming part of NTwitter does is that passes back a stream. And the stream itself can listen for events. A big part of how this is event-driven is everything can react to events. And in this case, the stream is listening for certain events. It's either listening for an error, the first thing that happens, in which case it can log the error, tell me what's going on, and maybe exit the program. Or if data arrives, it has to do something else with the data. In this case, it's going to emit the data as a tweet. And the left-hand word tweet here says that it's going to emit it as a tweet, as a label called tweets. So that on the front end, I can listen for that event called tweet and then do something with that. I know it's going to be a tweet because it's called tweet. And that's basically the app. That's the back-end service for the app. Now, if I was to jump across to the front end, let's see, there's a JavaScript page that deals with this. I'll start with the home page. If you can see it there, I'm calling a function called tweets and passing in a bit of data just to tell it what to listen for. It's looking for a search phrase. And optionally, I can tell it to use a template. It uses this built-in template otherwise. And I tell it where on the page I want to put the tweets. There's a div called ID container. And I tell it where to get the actual tweets. In this case, it's running locally on my machine. It could be whatever URL you set it up at. And the maximum number of tweets to get at a time, in this case, is 15. And this is using the jQuery plugin. I won't go through every line, but the basic thing that's happening is that this is, it's getting the data, and then it's parsing it through, it's using handlebars to actually parse that through a template. And the template itself then returns a bunch of HTML, and that could be stuck into a div on the page. And once it's done that from the search results, it then sets up a listen for more tweets. And what it's doing here, it has an event within this as well. It's listening for the event tweet, which we saw on the back end. When it passes through tweet, it has its function that it calls called add to top of list, passes through the data and the various settings for that. And that just takes the data, sticks it through a template, and continues. And that then just ticks over, listening for tweets. And anytime a tweet comes through, it'll appear at the top of the page. So that's available if you want to download it and have a go at it and maybe improve it if you like. It's only an early version of the app, so I welcome any pull requests if you want to add something to it. You can either download it from hop.ee tweets or you can look it up on GitHub as well. So if you've made an app and you want to get it out onto the web, there are a few ways you can do it. You can either host it yourself, and Node it's based in JavaScript, so it runs pretty much anywhere. It's quite straightforward to set it up if you have a Linux-based host, maybe you're on the likes of Linode or something. And that's something I do for a few apps. So I just set it up in my own version of Node running on Linux. Otherwise, you can deploy it through various services. There's a couple of ones that offer a free starting platform. There's Appfog and there's Heroku, and it's free to get going with them. They even have some extra services attached. You can add a database and Redis and things to that for free if it's a test version of the app. And there's NodeJitsu as well, which has some nicer pricing plans as well. Although I don't think it's free, but it starts off pretty cheap. It's a few dollars a month. So to summarize, if you're thinking about getting into Node, at least what really attracted me to Node in the first place, it's a nice way to get to the point of making things fast. And if you're a JavaScript developer, then it's pretty much a no-brainer that you can get into using Node. If you know a bit about JavaScript, you've already got a head start in that you know some of the basic ideas of how to use Node. But what really makes Node great is that if you're writing in a non-blocking way, using events and making the most of the single thread that it offers, it can be incredibly fast and incredibly stable. This MacBook Air itself, the basic HTTP app, can be tested to and run over 20,000 simultaneous connections at once. If you're running the likes of PHP or some of the server-side technology, it would scale up, wouldn't scale up to that kind of level. It would just crap out too fast for that. Not to say it's crap, but it's just a different use case for it. There's a great community around it. There are loads of modules being produced all the time. There's people that are really actively contributing to it, improving the software all the time. And it's great to be part of that and to feel like it's a good opportunity to actually add back to the community and make your own modules too. And Node encourages that. And for me, being a front-end developer, it appeals to me that it's all JavaScript. Further to that, when you see stuff like streams of data moving around the place or streams of tweets arriving on a page, it's amazing just that how a few lines of code can go into making that happen because it's built into Node. All this streaming stuff is just great. But on the other hand, there's some applications that wouldn't be well suited to Node. If you're doing lots of very sort of heavy applications that might need to process large numbers or to really take up the CPU for a long time, anything that's blocking, that's going to block the whole CPU, and Node can't really help in that. And there's a bit of a learning curve. This isn't browser-type JavaScript where you can maybe use jQuery or some handy kind of wrappers around JavaScript to make it easier. You can use CoffeeScript, but the way of programming has a bit of a barrier to entry in that you need to get your head around the order of execution of the JavaScript. It's caught me out a few times where I've maybe tried to set up a function, expected data to be available at a certain time, and then for some reason it wasn't. But the way to do it then is to nest the code and to be aware of where things are at every moment. But if you can get your head around that, it's a very satisfying way to make apps and something I've enjoyed getting into and I want to do more and make more apps with. So if you want to get started, go to nodejs.org, and it has installers there for Windows, for Linux, and for OS X. And just try making something. That could be a module. If you want to make a module, look for the way that the code works and see if there's any way you want to improve it. Maybe solve a small problem. But what Node excels at is getting you to the point where you can just think of a small problem that needs fixed, and then a few lines of code put together something that just fixes it. And along the way, if you want to check this out online, there's some links here to other talks where people go into more depth and more detail about some of the stuff I started on tonight. Ryan Dahl's intro is a great way to start to really get the idea behind Node and why it was built. And Jeff Kunkel gives a good talk called Node.js Explained. He goes into more depth about the event loop and why that matters. And Tim Caldwell goes into more information about the programming styles and the various ideas you can use to make the most of Node. And then if you need some help, the Google group is excellent, but sometimes even better, it's a good idea to talk to people. And there's a fantastic meetup that happens every month called Node.js Dublin. It was every couple of months. I think it's getting up to now the point where it's every month. So it's a monthly talk where they have 3 or 4 people come along. There's beer, there's pizza, and interesting people. And it's over the engine yard is where it's held. I'd recommend taking part in that. It's great. And that just leaves me to say thank you very much, and I hope this has been interesting. And do you have any questions?
Any questions, sir? Yeah, if Node.js is a runtime based on V8. Is the runtime for V8? Like how was it run?
Sorry, I can't hear you. What was that? Yeah, if you had a mic, that'd be good. Sorry, what was that?
what is it using to run JavaScript?
What do you need to run the JavaScript app itself or to run Node, like locally?
What does Node.js use to run the script?
As far as I'm aware, it's based on the V8 engine, the same thing that powers Chrome. It's essentially a wrapper to that. There are a few C modules essentially between that and the V8 processor, but essentially it's all JavaScript, and then that does the processing itself. Is that?
Then would it be possible to make a kind of fork the interpreter and make it more efficient? But like JavaScript uses only 64-bit double for numbers. It would be possible to make 32-bit integer for numbers.
Honest answer, would it be possible to actually fork the JavaScript interpreter and to extend it to maybe make different use of numbers? That's not something I'm quite qualified to answer. It might be a case where you need to go deeper than just what Node offers, because it would be limited, I think, in terms of the way JavaScript works, especially the way it handles numbers. I think it's kind of deep down in terms of the system and how that works. But yeah. Hi.
Do you use any testing frameworks, like Mocha?
Do you use any what, sorry?
Testing frameworks.
Testing frameworks, there are some. Mocha is a good one. If you want to get into unit testing, that's a good way to do that. Personally, I like to try 2 ways of testing if possible. Mocha would be a good way to do unit testing, but you can also add a layer of more functional testing using the likes of Casper.js, which is a wrapper for Phantom.js. It's a headless version of a web browser that you can control through a series of commands. And what you essentially do is you tell the headless browser that's within the computer, you tell it to go to a page, to maybe click a certain link, to expect a certain thing to happen. And you can make a list of tests and asserts that way that then you can test it 2 ways at the same time. Especially with web apps, I find it useful to test it as if someone's really using it, as well as to test the underlying logic.
And do you automate using Casper.js, or I saw you using Branch.js there? And can you actually integrate Branch.js with Casper.js?
I haven't done so myself. I couldn't say, but Grunt.js is pretty powerful. I imagine you could actually, if as a queue up the events, you could have it run the Casper command. I would imagine so. Any other questions?
Just one more. When you deploy Node.js there, do you put Nginx or anything in front of it?
Yes, I would say for anything that's going to get a lot of web traffic, it's a good idea to have something like Nginx to handle the static assets. You don't want to load up Node every time that maybe you're serving an image or serving a CSS file, so I'd use it for that. I also use it because on my server I have some Apache applications too, and it can be a basic router between the two, and it can direct the requests to the right place.
Oh, would that slow down Node.js though, if you put Apache or something in front of it?
I wouldn't put Apache in front, but Nginx is good. I think Nginx is very lightweight and fast. And in my tests, I've tested another app I have with Blitz.io. I found that it was very steady for any requests. It was like 40 or 50 milliseconds response. It started up a little higher and then settled down and just stayed at like a steady 50 milliseconds all the time, no matter how many users hit it. So I didn't see any significant problems using Nginx in front. Yeah.
Yeah, just one question about the network. You were saying that you've got 2 like versions of Hello World, right, like that, and it has one is with back from this and one is just printed directly out.
Yeah.
If you've got like latency in the system or something like this, and never mind like processing, but if you're just receiving information at different speeds, like on different times, you're going to get into a situation where you have to kind of set up, blocking the system in order just to actually get those requests back. How do you balance that?
So how do you manage the order of execution if you can't predict what's going to happen with the system? Like it could be slowing down for any number of reasons, not just disk access.
Yeah.
There's a cutoff point with Node in that it looks at it and says anything that's in the order of execution in terms of just executing commands, they happen from top to bottom. But anything that's going to be blocking in terms of set timeouts or a loop, like going through an array of items, they're all going to be asynchronous, and they'll happen in their own way, and it'll carry on until they're finished. So that's the starting point. But if you want to take control of that, you don't have to just accept that and have all these different nested kind of callbacks. You can use, there are some modules that help take control of that. There's one called async, And that can let you introduce more of a waterfall model if you want to make sure it waits for certain data to be available before carrying on. It can give you more choice in how you approach your program. But async is kind of handy for that.
Can you communicate between asynchronous tasks? They share data, or this will not call that?
Can you communicate between which, sorry?
So you fork off waiting on I/O, you pass data so that way, so that task is waiting.
You can, well, you can make use of callbacks would be the way I would normally do it. Or you can have an event. You can have a listener elsewhere that says, listen for the event done. And that event could be then emitted by whatever is running elsewhere.
Say the communication isn't done, say there's something that happens partway through communications that it's been of something else. So the original task has to be done. There's any way to communicate between asynchronous tasks.
So you're asking, is it possible to kind of break a process that started in terms of an asynchronous event when it's already out there? I'm not sure. That's the short answer. But if I understand you right, you're asking, would it be possible to have some asynchronous processes happening and you can't predict when they'd finish, but you want to then communicate with them again after they've already started, maybe? And
it's not necessarily from the main event, maybe from the other asynchronous processes.
I think it would depend on the case, really. It might be a case of looking to set up some events that would be listening for different steps within the process and try to break it up into smaller pieces, maybe. Rather than start one big process and then just expect it to be always listening. It might be handy to break it down. But again, I guess it might just depend on the use case, too. I'm not terribly sure, really. But the likes of async might be useful if you do want to take control of the order of execution and have some cases where you did want to wait, but other cases where you didn't, and try to combine them. Is there anything else?
How stable is it?
How stable? All reports I've read is that it's extremely stable and extremely fast. The actual core code itself is extremely fast. The programs you write might not be. They're in, not necessarily, but they're in one thread, in that if that thread breaks, the whole program stops. So you could have 200,000 users on something at the same time. You don't want that thread to break. So the way of approaching that is good use of callbacks that handle the error propagation. If an error comes through and it's not handled, it'll just stop execution entirely. And that's something to look out for, just not let happen. Instead, you can have an error callback that reports the error. And another approach is that some people let their apps fail, and instead they have something else listening to the app. There are modules that look at what the app's doing, and if it stops working, they'll just kick it back into action again. The way Node is set up, it's very fast to do that. You can have it fail and be back up again so fast that most people wouldn't even notice at all. And it's a reasonably legitimate way to do it. If there's something outside of your control that maybe makes it fail, you can sometimes just get it to kick back into action again. Hi.
Do you have any other examples of things you can do with Node.js or actual live services that are actually using Node.js?
Yeah, other examples of apps that use it. I was going to talk about one tonight, but I didn't want to go on too long. There was an experiment I put together a little while back. I wanted to build a service for discovery of random music. And to do that, I needed to get a lot of data, and I needed to then serve up that data through a web app. So I built 2 Node applications to deal with that. And I put it up here at beta.hop.ie. And what it does is it gives you a stream of albums, all of which are available on Spotify. And you can flick through and just keep going until something catches your eye, and then hit play, and it will play the album. And why Node's good for this? On the front end, it doesn't necessarily have to be Node. It could have been a Snatch wrap maybe on the front end. But in terms of just getting it built fast, it was very light to build it with Node. There's not a lot there. It's basically an Express front end. And all it's doing is using a database, a read-only database, where it's reading data. But the second app, it has no interaction with the web at all. There's a second app that runs by itself in the background. And it has 2 modules. There's a module for interacting with Amazon with its product API. And it runs a random search in the music section. And for every 10 results it gets back, it then runs it through the Spotify API, which is the second module. And that's a callback to the Amazon API, I call it. And then if there's a match, if it gets data from Spotify, it puts it into the database. So it's like a little worker that just builds up this database of stuff. And in terms of creating a quick sort of proof of concept to get to the point where it worked, it was easy to use Node in that I could build it as 2 small applications, get them working fast. And occasionally the worker would just break because maybe it got some data it didn't expect or handle properly. And I could restart that without affecting the web service because they're 2 different apps and they work independently. But they share the database. And I think the main advantage for me in terms of doing that was that it was just quick and easy to get going, to get to the point where I had something to see and I could get off the ground fast. Has anyone else used any applications that make use of Node? Anything? A good example is, well, if you go to meteor.com, Meteor. They have a video if you want to see some interesting examples of how you can make use of the real-time stuff, the streaming between apps. They give a walkthrough with there's a list example where people can add things to a list, take them away, and they have a second browser window open at the same time, and you see it updating at the same time.
Sorry, I heard Meteor is not really like 100% Node because it has its own ecosystem, right? It doesn't use NPM either.
So Meteor, it's developing its own system quite separate from Node. It's based on the similar idea, but it is spitting off from Node in the way it works. If you want to be more Node-like and use that kind of approach, you can use something like Socket Stream. I think there are other alternatives that are actually based on Node and use NPM as well.
Any more questions?
Any more questions?
Yeah.
Sure.
Just when you debug Node.js a Node program, do you just show a debugger in there, or is there any other program you can use to debug Node?
That's a great question. Any other ways to debug a Node application when you're debugging it? You can log out stuff if you like. That's one way. It's clumsy and it's not a great way to do it. You've got to keep restarting the app. But there's another thing called, I think the name, Node Inspector. If you've ever used the inspector within Chrome, Node Inspector is an add-on for Chrome that allows you to see what's happening in the back end of the JavaScript from the browser. And that can be a handy way to debug your application, to see what's happening at various points, introduce breakpoints if you want to, and analyze more carefully what's happening. Otherwise, you couldn't see what's happening in the back end because it's off in the back end.
So just if you put a debugger in the middle of your application, will you stop, like, you can see it from the console? If you put a debugger in your, like,
I guess so. That would be one way to do it. I think it's, well, personally, I find it more comfortable the way I would develop it, in that I was already using Inspector for the front end, for debugging the code and the scripts on the front end. I find Danny Coates' Node Inspector quite a handy way to do the same thing and just see the same structure of the data on the back end. But Node being Node, I think there are any number of ways to do it. That's a perfectly legitimate way to get through as well.
Thanks very much.
Thank you.